Welcome to our K.S.RCT YouTube channel. Myself, Dr. A. Ramesh Kumar, Professor in the Department of Mechatronics Engineering, K.S.Rangasamy College of Technology, Tiruchengood. Today, the topic we are going to see is CAM mechanism in area of machines. CAM. A CAM is a rotating machine element which gives reciprocating or oscillating motion to another element is known as follower. The cam and the follower have a line contact and constitute a higher pair. The cams are usually rotated at uniform speed by a shaft, but the follower motion is predetermined and will be according to the shape of the cam. The cam and follower is one of the simplest as well as one of the most important mechanisms found in the modern machinery today. The cams are widely used for operating the inlet and exhaust valves of the internal combustion engines, automatic attachments of machineries, paper cutting machines, spinning and weaving machineries, feed mechanism of automatic lathes, etc. The followers may be classified under according to the surface of contact, knife edge follower. When the contacting end of the follower has a sharp knife edge, it is called a knife edge follower. In knife edge follower, we can found excessive wear and considerable side thrust exists between the follower and the guide. Roller follower, when the contacting end of the follower is a roller, it is called a roller follower. In the roller follower, wear is greatly reduced and also the side thrust exists between the follower and guide. Flat-faced or mushroom follower, when the contacting end of the follower is perfectly flat-faced, it is called as flat-faced follower. It can experience the side thrust between the follower and the guide is much reduced. Spherical-faced follower, when the contacting end of the follower is in spherical shape, it is called a spherical-faced follower. It minimizes the surface stress. Again, the classification of follower is classified according to the motion of the follower, reciprocating or translating follower. When the follower reciprocates in guides as the cam rotates uniformly, it is known as reciprocating or translating follower. Examples for reciprocating or translating follower are cam with knife edge follower, cam with roller follower, cam with flat faced follower, cam with spherical faced follower. For oscillating or rotating follower, when the uniform rotary motion of the cam is converted into predetermined oscillatory motion of the follower, it is called oscillating or rotating follower. Example for oscillating or rotating follower is cam with spherical faced follower. According to the path of motion of the follower, it is again classified into radial follower or offset follower. In radial follower, when the motion of the follower is along an axis passing through the center of the cam is known as radial follower. Knife edge follower with cam, roller follower with cam, flat faced follower with cam, spherical faced follower with cam, oscillating follower with cam, which are in line with the axis of the cam is called as radial follower. In offset follower, when the motion of the follower is along an axis away from the axis of the center, then it is called as offset follower. The cam may be classified into radial or disc cam. The follower reciprocates or oscillates in a direction perpendicular to the cam axis is called as radial or disc cam. Examples: knife edge, flat face, roller, curved or shoe, spherical shape followers are some of the examples for radial or disc cam. Next, cylindrical cam. The follower reciprocates or oscillates in a direction parallel to the cam axis. The follower rides in a groove at its cylindrical surface. It is called as cylindrical cam. Cylindrical cam with reciprocating follower is one of the example, and cylindrical cam with oscillating follower is another example. Apart from that, the cams may be classified into tape or radial cam, wedge cam, barrel cam, end face cam. Motion of the follower may have the following motions during its travel. They are uniform velocity motion, simple harmonic motion, uniform acceleration retardation, cycloidal motion. Now we can see how to construct a cam profile for a radial cam. In constructing the cam profile, the principle of kinematic inversion is used, that is, cam is imagined to be stationary and the follower is allowed to rotate in the opposite direction to the cam rotation. Example 1. A cam is to give the following motion to a knife edge follower. The motions are outstroke during 60 degree of cam rotation, dwell for next 30 degree of cam rotation, return stroke during next 60 degree of cam rotation, and dwell for remaining 210 degree of cam rotation. The stroke of the follower is 40 mm and the minimum radius of the cam is 50 mm. The follower moves with uniform velocity during both the outstroke and return strokes. Draw the profile of the cam when the axis of the follower passes through the axis of the camshaft. This is the problem given. So what we have to do is, first we have to construct the displacement diagram. The displacement diagram can be constructed in the following steps. Draw a horizontal line AX for 360 degree to some suitable scale. On this line, mark A is equal to 60 degree to represent the outstroke of the follower, ST equal to 30 degree to represent dwell, TP is equal to 60 degree to represent return stroke, and PX 210 degree to represent dwell period. Draw vertical line AY equal to the stroke of the follower, that is 40 mm, and complete the rectangle as shown in the above figure. Divide the angular displacement during the outward stroke and return stroke into any equal number of even parts, maybe 6 or 8, and draw vertical lines through each point. Since the follower moves with uniform velocity during outstroke and return stroke, displacement diagram consists of straight lines, join EG and HP. To complete displacement diagram is shown in figure by AGHPX in the figure. Now we are going to see the construction of profile of a cam when the axis of the follower passes through the axis of the camshaft. The steps to be followed are: draw a base circle with radius equal to the minimum radius of the cam, that is 50 mm, with O as center. Since the axis of the follower passes through the axis of the camshaft, therefore mark trace point A as shown in the figure. From OA, mark angle AOS equal to 60 degree to represent the outward stroke, angle SOT equal to 30 degree to represent the dwell, and angle TOP equal to 60 degree to represent the return stroke. Divide the angular displacements during outward and return stroke, that is angle AOS and angle TOP, into the same number of equal even parts as in displacement diagram. Join the points 1, 2, 3, etc. and O dash, 1 dash, 2 dash, 3 dash, etc. with the center O and produce beyond the base circle as shown in the figure. Now set up 1B, 2C, 3D, etc. and O dash H, 1 dash J, etc. from the displacement diagram. Join the points A, B, C, D, Mn up to Mnp with a smooth curve. The curve AGHPA is the complete profile of the given cam. Example 2. A cam is to be designed for a knife edge follower with the following data: cam lift equal to 40 mm during 90 degree of cam rotation with simple harmonic motion, dwell for next 30 degree. During the next 60 degree of cam rotation, the follower returns to its original position with a simple harmonic motion, dwell during the remaining 180 degree. Draw the profile of the cam when the line of stroke of the follower passes through the axis of the camshaft. The radius of the base circle of the cam is 40 millimeter. Now we are going to draw the displacement diagram as shown in the following steps. Draw the horizontal line AX 360 degree to some suitable scale on this line. Mark A is equal to 90 degree to represent outstroke, SR equal to 30 degree to represent dwell, RP equal to 60 degree to represent return stroke, and TX equal to 180 degree to represent dwell. Draw vertical line AY is equal to 40 mm to represent the cam lift or stroke of the follower and complete the rectangle as shown in the figure. Divide the angular displacement during outstroke and return stroke into any equal number of parts, say 6, and draw vertical lines through each point. Since the follower moves with simple harmonic motion, therefore draw a semicircle with AY as a diameter and divide into 6 equal parts. From points A, B, C, etc., draw horizontal lines intersecting the vertical lines drawn through the O', 1', 2', etc. at B, C, D, M, and P. Join the points A, B, C, etc. with a smooth curve as shown in the figure. This is the required displacement diagram. Knife edge follower. Draw a circle of 40 mm in diameter and in anti-clockwise mark the outward stroke 90 degree and dwell period 30 degree, return stroke 60 degree, and remaining 180 degree for outward stroke, return stroke. Then divide the 90 degree into 6 equal parts, what we did for the displacement diagram. Measure the points from 1 to B from displacement diagram and mark it in the radial lines. Similarly, do it for 2C, 3D, 4E, 5F, 6G, O-H, 1-J, 2-K, 3-L, 4-M, 5-N, and 6-P. Join the points B, C, D, E, F, G, H, J, K, L, M, and P as a smooth curve and draw a semicircle, draw a arc, take O as center, P as radius. From P to A, join the curve, you will get a required cam profile. Thanks for watching. Keep learning and growing with K.S. Rangasamy, College of Technology. Thank you.